Hey, hello. We'll start the streaming in a few minutes. We'll wait a couple minutes for everyone to come in. And welcome to the Wisconsin.net user group. But it was logged by Mitchell Sellers. And we'll start in a couple minutes. Welcome. All right. Thank you, everyone, for attending. Hello, my name is Jason Von Ruden, and I'm the president of the Wisconsin.net user group. And we have monthly meetings covering the latest technologies, including web, mobile, cloud, .net, and more. Thanks for being here. We have a few announcements about upcoming events. We have Milwaukee Tech Week coming, and I'll put something up for that. Milwaukee Tech Week is October 3rd through the 7th, and it's a 5-day event, a series of events in person and virtual, where you have a chance for the Milwaukee tech community to come together and celebrate technology-focused and community-driven approach. So please check that out. I will post information about that in the description of the meeting, so you'll have a chance to see that. And then also next month, we have Don't Build a Distributed Monolith, Avoid Doing Microservices the Wrong Way by Jay Tower. So please check that out for next month and tune in. I really appreciate it. And today we have a talk by Mitchel. We're going to be talking about But It Was Logged, Avoid Doing Microservices the Wrong Way. I think that's all we have. We can kick the meeting off, and welcome.
All righty. Well, good evening, everyone, and really appreciate everyone being here this evening. Going through, so basically we're talking about logging. Oh, geez, sorry. Let's go. Of course, PowerPoint decides to be fun with me. So my name is Mitchell Sellers. I'm a Microsoft MVP. I run a company called Iowa Computer Gurus based out of the Des Moines, Iowa area. My contact information is up here. We'll make sure to circulate it a little bit here later as well. If you have any questions, please do feel free to drop something in the comments, etc. I'll make sure to get as much of those questions answered as I can tonight. The goal here is really to give you information that you can go back and use tomorrow at work. If you have questions that you don't want to ask here, things that are maybe more confidential or private, feel free to send me a message. My GitHub is linked here as well. The code samples that I'll show towards the end of things tonight is out there, as well as these slides and all of the other examples. So anything and everything from this should be available for you pretty easily. So just kind of start out, what is the goal of what's the goal out of this talk? What do I want you to leave here with tonight? And the idea behind this is really focused on understanding the purpose of logging and what you can do with logging and what you can't do with logging from an organization perspective. Although this sounds a little bit interesting, it's one of those things that we always talk about logging and we see examples, but we don't necessarily look at logging as it relates to business and how we actually do logging effectively, or what we should be looking at logging to be able to accomplish that maybe we're not doing today. I also want to take then a look at escalation protocols and how you take your logging implementation and take it from something that just gets done and sits back in the corner to something that is overall your actionable escalations. So for example, what is the right process to take an error that happens in a production environment and actually escalating that and getting that to somebody that can actually do something with it, right? So with that then becomes the sensitivity aspect of it as well. So we want to talk about how those pair together. How often do we escalate? How do we accomplish those goals? And then really we want to talk about the real key piece here, which is logging in .NET Core and how we accomplish everything that we have been talking about, but how do we do this within the .NET Core space? Because it's an area that, although has support from Microsoft out of the box, that's part of the default implementations, is not necessarily documented to the greatest level. So a little bit more about why I chose this. What's my experience? Why is this becoming something that I feel necessary? And even more importantly, why is it something that I'm getting asked to be talking about at various conferences, events, things like this. And the idea behind it started because it's something that's often forgotten. You do a file new project in Visual Studio for anything .NET Core. Your app settings JSON file has a logging configuration section in there. It has some values in it. And there's so many people that just move on from there. I do a lot of work on the security side of things. So I'm looking at sites, looking at history of OWASP top 10, other security breaches, and things of that nature. And what I find is that logging comes up in two of the 10 top 10 areas. There's an area talking about broken access control. So in other words, giving somebody access or permissions to do something that they shouldn't, or not logging the fact that they weren't able to do something. And then also the last one, which is insufficient logging and monitoring. Wow, that's a full-on item. And the idea behind all of this is that logging is important, and it's important in multiple capacities that we often don't talk about. We're not just talking about developer logging. We're not talking about, IIS logs or server logs or other things. We're talking about a cohesive look at logging and tracking and history and monitoring so that we can understand what's going on in our environments and the things that we might need to do to take action. And with all of this, right, there's many paths, but there's not a single way to just get things done. There's not a easy button, if you will, where you can just simply say, I've checked the box, I've got logging, I've got everything I need. So it gives us something to be able to, really work forward to something that's going to be beneficial. The out of the box implementation, so what you get from Microsoft by default, absolutely leaves questions. There's a lot of people that think, oh, logging doesn't work, this doesn't go anywhere, I don't know why this is turned on. And it's because of some limitations that exist with the out-of-the-box functionality. So we tried to really look at a way to take and elevate what we're doing so that you have an implementation that's going to work the way that it needs to be. As we get started, I would encourage each of you to ask a few questions of yourself and be thinking about this as we talk through things this evening. And the first thing is, do you actively include logging in your code today? And although, yes, we are talking most specifically tonight about ASP.NET Core logging, I would really encourage you to think about logging in any other capacity as well. IIS logs, server logs, system logs, SQL logs, anything and everything that is logging, a lot of the things that we're going to talk about tonight will be applicable to those other log sources as well, not just the things that we're looking at. Beyond that, do you have an escalation protocol in place for logging events that happen today? This could be anything from, oh yeah, errors that get recorded to the Windows Event Viewer actually go into our software management solution. Or this fires off an email, that kind of thing. It's just, do you have anything to do escalation? And if you don't, what things could be different if you did? And then lastly, do you look at your logs? So one of the things I get from people a lot is, yeah, we have logs, we store them. And you really need to ask yourself, do you look at them? And is it on a regular basis? And the reason for this is really a understanding of what kind of risk you might have out there. If you have logs, do they have enough detail? Do they have too little detail? Do those log messages, do you have the right amount of retention, right? Understanding and looking at those and validating those logs, whether it's a once a month, once a quarter, once a year, some sort of frequency to understand and validate the integrity, just like we would go through and validate the integrity of a backup solution or an ability to do a disaster recovery, a BCP plan, right? We would want to be doing the same kinds of things. So as we kind of go forward, be thinking about this and how it relates to your organization as we talk through the various elements of logging within .NET Core. So as we look at .NET Core logging, it's important to kind of figure out what we can do with logging in .NET Core within our particular applications. And the most logical thing that people think about is the diagnostic information, the debug style messaging. Why is something working the way that it is? It's often also attributed to usage in lower level environments, in development environments, and staging environments. Oh gosh, I started this method with this value, or I did this and it had this result, those kinds of things. And although that is true, it's often used in lower level environments. This is what people think about. Logging is also far more than just diagnostic information, or at least it should be within your application. Audits are another big piece that is often utilized in the same logging infrastructure. Think of this as users tracking messages or documenting what a user is doing, their actions, their steps through your program. Think of this typically in that critical path scenario. Oh, this user just accessed privileged information. This user just clicked the reset system button. Oh, this user deleted something, right? Those critical path items or anything that is sensitive data access. This gives you that ability to give that breadcrumb to figure out what a user did. In the future, if we find, for example, that user had malicious intent, any of those kinds of audit style messages would allow us to walk backwards, right? And figure out, what did they do? What might they have accessed? What do we have to go back and adjust for a little bit later? Some good examples to think about along these lines are things like credit card transaction logging, admin actions. ASP.NET automatically does this with identity, for example. An invalid password is logged into the log stream. Whether or not you do something with it is a whole nother choice. But the idea here is you want to be able to keep track of those things that are exceptional events. And that's oftentimes areas of privilege or otherwise, so that you can determine what exactly that person did. And lastly, we can also utilize the same logging system to do exception reporting, to get knowledge of when our application has experienced an issue. If we utilize a robust logging infrastructure and we record an error, we can add contextual information based on the timeline and overall process to be able to understand what was going on around the time that exception occurred. This allows us oftentimes to be able to be preemptive on validating these potential issues that are impacting users. So rather than waiting for a user to do something, have an exception occur, them submit a support request, the development team already knows, oh gosh, yeah, they were on this page, they clicked this button and this blew up, right? It makes it so that you can be more actionable on those exceptions and be able to get something done for somebody before they even necessarily ask. Or at minimum, when we have to start digging, we'll be able to accomplish things in a more timely fashion. Now, as we start talking about all of this, we also then have to take a look at the other side of the coin when we are deciding what and how we're logging. The sensitivity of the information and the security of this is equally important. So when we talk about the sensitivity of the information that we're logging, we want to look at the security. And we're not talking about just the physical security, as in who can access the logs. We're also talking about things like retention. Do I need to know it? And the individual information that is included in those log entries. Some examples of things that I've seen in talking with individuals over the years with regards to their login configuration. Physical security examples of poor decisions would be those that decided that their log files should be stored with a .txt extension, which means they're automatically servable by IIS. Love to tell you that I'm joking that you could hit a website and go log.txt and it would bring out all of their login information. I've seen it more than once. So making sure that you're thinking about the physical security, not just in can it be served by the web application, but also what are we doing to get people support access to it? This is one of those things where we often see system administrators and developers fighting for permissions. I don't want the developer, and a developer never should have the physical security access to get the logs out of a production environment, but they need to be able to be available to them to be able to support. And that's where putting some of these processes in place come in very handy. Retention rules or retention examples, right? There's only a certain period of time that a log is actionable. Once something has happened, it may not be needed over a period of time. For example, credit card disputes are often done and cleared within 60 days. So keeping e-commerce transaction login history well beyond 60 days may not be as valuable for you. And in all of this, we need to make sure that the information that we're including in these logs is valid enough to be actionable, but doesn't introduce its own security vulnerabilities, because oftentimes these log entries are stored in plain text or stored in systems that are allowing people with more people to have access to them. So for example, when we're logging an e-commerce transaction, we do not want to log the credit card number. We don't want to log the expiration date. We want to log something that would allow us to be able to associate that action to something else. So, unique identifiers, other kinds of things. We want to be careful about the information that we're storing. Now, it's a very fine line when we start talking about all of this. We need enough information to be able to recreate the situation, but we need to make sure that we don't violate privacy concerns. Now, for those of you that are working with things with an international audience where you have concerns such as GDPR or other international regulations, it is something that you have to take even more consideration into, because GDPR limits what you can do with the information and activity tracking of those utilizing your applications. Now, we start to talk about what we can log and where we want to log it and how long we want to store it. Then we have to start looking about escalation, the concept of taking those logs and making them more interactive, something that isn't just a text file stored somewhere on a server that nobody's ever going to look at. So we need to look at how do we escalate? Who do we tell? And what we've found is that it becomes imperative to put that log information in the best location as possible. And this will outline the success or failure of an implementation. If you go to an extreme for visibility or notification, you can reduce the effectiveness of your logging process, and especially anything with relation to an escalation protocol. A great example of this is a customer of ours that thought it would be a great idea to send an email every single time a 404 was encountered after a new website was implemented. As you can imagine, this did not go well. The Google bot hit the site, the MSN search bot hit the site, a number of other things went out, and there were thousands upon thousands of 404s that got logged. Thousands of emails were sent. Filters got created that would take any information from the login system and put it immediately into that digital trash can. They lost all integrity because they overwhelmed the developers or the support team with information that wasn't actionable. Now, we obviously want to do things, but we might need to start looking at how do we deduplicate, or how do we limit the throttling of, okay, I need to know there were 404s. Do I need an email every single time? Probably not. Do I need to know that there was maybe 500 404s in the last hour? Probably something that we want to look at. So this is where people start to run into the situation of, well, how do I do this? How do I validate or make these changes or make these escalation protocols with what we get out of the box with ASP.NET Core? And the reality is we don't have a lot of options. The default configurations for logging, we have the ability to take our log entries and write them to the console. Well, that doesn't give me any help. We can write them to the debug window, which also doesn't help me. We can write them to application insights. That could help me, but it has an Azure dependency. And event source, which for those that aren't as familiar, that would be like your Windows system log, your application logs. Again, depends on what software you have in place. It's very possible that you could utilize that to go out and do something. If we go look though at third party and open source, we have endless options. We have the ability to go to file, email, Azure storage, SEQ, a number of other third-party, logging systems, Loggly, Stackify, Exceptionless. There's all kinds of them that exist out there today. And the idea behind all of this is we might need to do something different based on the severity and the nature of the message. So one of the things that's an absolute is that if we want to implement a good logging strategy with an escalation protocol, where we're able to do things, we are going to have to start looking at a third-party implementation. The good news is we can stay almost completely no cost for almost everything, but it's something that you may want to, implement other choices that will result in some additional cost. And we'll kind of talk about that here in just a little bit. When we talk about then an escalation pattern, what does that look like? And what we've found is that oftentimes using a dual configuration split by severity is the most effective way to get started within an application. And the idea behind this is errors would be our biggest severity, and we want those to be logged locally so that we have a full history, but then we want to send those to an external service. Now that external service could be Loggly, it could be Exceptionalist, it could be SEQ, which is what I'll be talking a little bit about tonight, or any other number of platforms that exist out there, right? It doesn't really matter. The idea is we want to get that to an external service. We want our application to focus on doing its job. It encountered something that's wrong and needs to log it, but its responsibility should really end there. Everything else, we want to log it to the file system. We want to do rolling 30-day history. And in a perfect world, right, we want to also ship that off to the external service because maybe that external service is going to do something different with it. The idea behind all of this is we want our application to focus on writing the log entries, properly categorizing them. Make sure that an informational message is really informational. Make sure that a warning is really a warning, that an error is an error, and that we're not putting things in those log messages that we shouldn't. Everything else, alert thresholds, how you send it, does it get emailed? Does it go into a task queue? Do you automatically create a work item in GitHub every time something happens? Ideally, that's all done by an outside service. And the idea behind this is I don't want to have to reconfigure my application if something changes. It's a bonus if you can dynamically change those login levels from outside of your application. Think of a production issue, and you want to all of a sudden dial the logging up to a higher severity. Being able to do that without restarting the application, without making a code change, would be fantastic. A lot of the tools support that SEQ, which I'll show a little bit of tonight. Loggly and a few others, they all do it. It just depends on the particular tools. I'm not trying to tell people one tool or the other. I just happen to have more experience with SEQ because that's what we've personally decided to work with. And, anything that, otherwise, feel free to share in the comments if you're using a log aggregator or system that you're fond with, because I'll make sure to call attention to any of the other ones that folks are using. But the idea is we want to be able to manage that information. The other thing is that by utilizing a process like this, where we take it from the system and get it into something else, we're going to get access to our logs a lot better. We are going to be able to take that log information and get it off of the production server and into a logging system. By doing this logging system transition, we will be able to get developers access without giving them access to the web servers, not giving them access into these production environments that we all know would be a really bad idea. So where does all of this come together? How do we start tying this into the .NET 6 world? Well, I want to start with that default configuration, right? Out of the box, if you do file new project, you're already using logging. You already have access to things. It's just most people don't think about what you are actually looking at. You get logs to the console. It's turned on by default. It's already configured, but almost everybody ignores it. The output targets are limited, which we talked about. But the key uniqueness with .NET is that we have a single logging stream where everybody writes to the same logging system. So in other words, Microsoft is writing to the same log stream as your application. Entity Framework is writing to the same log stream as your application. By listening to and digesting the information from this log stream, you're able to take and be able to look at much more reasonable understandings of why things are doing what they're doing. When Entity Framework starts, you can see all of the error messages or warnings that might be there, things that might not even show up when you're creating migrations. You'll be able to look at ASP.NET Core. Why did it pick a particular route? Why did it go to this controller over another controller? All of that kind of information is there. We just have to control whether or not you can see that out of that login stream. Now, third-party support is where we start talking about needing to bring in those other output targets. I'm going to talk today specifically about Serilog, which is an open source, non-paid for, free collection of logging extensions. They have a number of different logging sinks or destinations, which is where you can take those log entries and write them to. There are free abilities to write to log files, to event source, to log4net. You can go to the Windows event log. You can go to Loggly. You can go to exception list. You can go to stack. Gosh, I can't think of a bunch. There's a bunch of them out there. And the idea here is I'm wanting to push you to a product, a way to be able to get these logs and take it from, it gets written to the developer console. I want to get it written to a place where we can do something with it. And with that, we want to kind of look at what can we do. Well, things that we can do that people don't necessarily think about is the ability to look at optimizations, bottlenecks, performance. All of this can come out in logging with default log messages that are already happening in your application today that you're just not keeping track of or you're not looking at. So we can see things such as Entity Framework Core is able to log out optimizations on model start, like I was talking about. You can also get Entity Framework to log every single SQL statement that was executed, how long it took. And it does it by default in a safe manner where you're not seeing the private data. So you're not going to see all of the parameter values, but you're going to see what SQL statement was executed, what parameters were passed to it in terms of it was a parameter for this field, but you're not going to see the individual private data. This allows diagnostics to be done really, really easily. You can take things as well, looking at how long did it take to execute an individual controller action. And you can do aggregation, those kinds of things very, very easily. Now, as we go forward, we obviously have the ability to write our log messages within our .NET applications. And it is important to understand what we are doing when we're writing log messages. If you've only been writing using the default behaviors, right, we're logging to the console, which is always a straight line bit of text. As we start building structured logging, things that are going to other destinations, it's important to understand what we're doing when we write out a log message. If we call log information and we pass it a message template and then one or more parameters, what it is going to do is it is going to note that the log entry that we're doing is user information with the parameter of user, and then it's going to try to call toString on each of the parameters that are passed to that parameter array. So in this case, we would have a log entry that looks something like this. Okay, this is fairly safe depending on what you have in that object. There's two things that are anti-patterns that I often see developers try to do. String interpolation, as soon as it was introduced, right, is a amazing thing, right? $sign before my string, and I can just put request in there and life is good. It's important to understand that you should not do that with log messages, because in a log message scenario, that first parameter is a message template. It is not just a message. So as you're going to these sophisticated logging systems that are able to identify patterns and use structured data formats, it is going to be able to, with the use of a template, find every single time that's been logged because it's a common event. If I were to do this and I wasn't using a message template, each of those log entries look different based on the actual string implementation that occurred later. For those that utilize tools such as SonarQube or anything else to do static code analysis, oftentimes there will be analysis rules that will actually catch and warn you if you were using string interpolation on a particular log entry, just because of that behavior difference and how much it results in something that you're not necessarily expecting or wanting to do. Now, the other behavior that occurs, though, with this is you do have the ability to dump an object rather than simply calling toString on it. So if I were to try to dump out the full user identity information, where I use the @ sign inside of the parameter, it is going to take the entire representation of that user object and try to serialize it to JSON and include it in my log. Now, what this results in is a lot of information being logged. And as we look at this, there could be private information in here. There could be something that really, really shouldn't get into these logs. So as you're doing your reviews, as you're doing your development, it is important to look at that message format in anything that you're doing and understand what those things are doing. Now, I have examples in the code that I'll be showing here in just a little bit that will help walk through some of those things. So it will be something very, very easy to be able to understand. At the end of the day, the goal that we're trying to get to is to where you can do with whatever system you want to use a situation where, hey, I have this error that happened. It was at this method, it was this result in this amount of time, and here's all of the other information that you need to become actionable. Here's the list of everything that's gone on within your application and let you be able to figure out what's going on, letting you drive into what information is here, up to and including things like what was the error, what was the event ID, what was the type, even maybe including some of your own information, which user was specifically encountering this error. Anything and everything that you can do. The goal here is to be able to make your logging actionable. Now, I'm using SEQ again. There's all kinds of other tools out there. They all have similar things. They'll just be configured maybe ever so slightly different. And the goal here is just to be able to really expand on this information to be able to do the things that you're looking to accomplish. Some resources that I'll share here, and I'll put this back up as we get towards the end here, but I'll kind of transition over into some code samples to talk about things that I do to take an ASP.NET Core application from the default template and move it into something where I have a good mix of login ability to look into what our application is doing and the ability to be actionable. This would be a great time if any of you have any questions about the things we've been talking so far. Feel free to share them in the comments section. Gladly answer anything that you might have right away here, and then we'll switch over to the code in about a minute or so if there's no questions. Alrighty, if there are no questions, we'll go ahead and dive into the code sample here. As a reminder, the code sample from this is available out in my GitHub repository. So you can access this. This includes the slides and everything as well at any time as needed after the session is completed. I'll kind of try to increase zoom here a little bit just to make it a little easier for everybody to see. So what I did for the purposes of this demo is I took a default ASP.NET Core MVC project, and from the default template, I went and used this as a way to basically create a playground, if you will, of logging configuration and logging examples within a MVC application. So as you go through and look at the individual content that's out here, what I utilized as part of the overall layout is I simply gave some examples of, hey, I want to trigger a warning. I want to look at Entity Framework Core. I want to look at a more complex login example. And so each of these individual views have some detailed information about once you clicked on this, what happened, what was the information, and how was it actually written to the log stream, so that when you're walking through and following things afterwards, you'll be able to look at. Entity Framework, I talk about the specifics of how you can adjust logging to look at various things within Entity Framework and how it writes out to that log stream. And then we talk about in the privacy example, it shows the ramifications of doing things incorrectly. For example, what happens if you accidentally do that dump operation on the request object. If you do this, for example, it's slightly more than 5 megabytes of data for each individual log message, oftentimes when this happens. The other thing that I did with this project is I'm a big believer in using dependency injection, properly unit testing your projects and those kinds of things. And for those of you that are listening, I am sure that we've all encountered that dreaded process failed to start message that we get when we forgot to register a dependency that was maybe needed by our code somewhere, or some other similar style issue. So what we wanted to do is we wanted to set up this project in a manner that ensures that anything and everything that could go wrong within reason would get logged, so that if we had an issue, we did not need to go reconfigure anything. We did not need to go do something else. So what this means is I wanted to be able to log everything, including the calls to start up in the app builder itself. So to do this, we had to do a couple of things. I wanted to make everything configurable from the app settings, because everybody's environments are maybe a little bit different. So I wanted to be able to replace and update configuration settings through deployment processes or other things, whether you're using GitHub Actions or otherwise to do your deployments. I then wanted that information to be read as part of our application start. Thankfully, Serilog supports all of this. So what we find is that in our app settings JSON in the example project here, we have a new section that's been added to our configuration. You'll notice that the login section that's there by default has been removed. It's no longer necessary. And in here, we are telling Serilog the various types of components that we're looking to use. I will come back to the minimum level here in a second. We also are telling it that we want to enrich our login with some extra data. Now, this concept within Serilog is where we can basically automatically to every log entry, have it enrich that log entry with additional information. So from log context, this is the concept where you can have a logging context with every request, and you can push a piece of data into it, and then every log entry that happens afterwards will still have that. So think of injecting the user ID, and then everything with the rest of that request, any login entries would have that user ID attached to it. We can enrich with the machine name, with the thread ID. And then the last one here that's really valuable and important is the correlation ID. A correlation ID, the concept here is that each web request will be given a unique correlation ID. So then every single log entry for that particular web request will have the same correlation ID. So then if you needed to backtrack a single web request and look at everything that happened with it, you would have a unique identifier that you would be able to track. From here, we also then tell Serilog where we want to write our entries to. So in this case, we say we want to write them to the console. We also want to write them to the file system, and we want to make some configurations. Our log file path is here. We want to only report on informational messages and more severe. And we want to update our output template to look a particular way. So we put in our tokens or anything else that we want to utilize. And then lastly, we can look at this minimum level configuration. The minimum level configuration, as I like to think about it, is the traffic cop for the information coming out of the login system and going to these right to destinations. So the default, that is like the actual knob on a faucet. That is going to control anything that comes out of your application. Does not matter what you specified in override. That is the default. So in other words, if I put my default here as information, I cannot tell other things that I want debug information because I cut the flow off out of my application right away at information. So a lot of times you'll see that this will become more granular at the default level. And then you'll override to be more restrictive a little bit later. But the idea here is that we can then override based on the namespace of where the information is coming from. So in this example here, we could take and say that Microsoft, by default, we only want warning. From system, we only want information. But Microsoft Entity Framework Core Database Command, we also want information. And what this would do is very specifically for Entity Framework Database commands, give us informational messages. And this is what gives us that output of all of the actual SQL queries that we've been executing. So by doing this, we're able to reconfigure. With your application, you could change this in real time. You could change this as part of your deployment. In one environment, you could have one set of configurations. In another environment, you could have another. You don't have to recompile your code. You're not necessarily changing anything with the day-to-day. If you're a user of SEQ, which is their overall system for being able to do things, you can also get even more fancy and use what they call a level switch, which is basically allowing you to be able to control things by default from outside of the system. And that's done here. I just included an example so that you would have it if you're going to look at it. Their documentation also covers it really well. So now that we have this overall configuration, we have to look at what do we have to do to get our project to build and work successfully. So we had to add a couple of package references, specifically here. And I'm sorry, this keeps getting added back in. We need to add Serilog ASP.NET Core. That's the base functionality for Serilog. We need to add the Serilog Enricher's correlation ID. So this is the piece that allows us to do that correlation ID. We need Serilog settings configuration, which is to be able to bring our configuration settings in from a configuration file. And then Serilog sync console, which I actually don't think that one's needed either. But basically, you can bring in the distinct references to the individual destinations that you want to go. We then look at our program CS. Now, I have done this utilizing the traditional project startup sequence, mainly because it looks, reads, and flows a little bit better, in my opinion, if we do it this way. You can do it with the single file startup sequence, but I find that it's just a little bit cleaner doing it this way. But the idea here is that we need to set up our own instance of configuration because we want to build our configuration file, read those settings from configuration even before our application has started. So here we build a new configuration, we set our base path, we add our JSON file, we add our environment variables, and then we build our configuration. Because then inside of our main method, we're able to set our logger configuration by reading it from our configuration. And then we can use a try catch finally here to actually then create and run our web host builder. This way, if any unexpected exceptions happen, right, we can catch it, log it as a fatal that our host had terminated, and then our finally here of closing and flushing the log guarantees that all of our log messages are done. So in the case of a failure, a missed dependency, unable to map a project of a type, any of those kinds of things, we're going to be able to catch those and write these. The only thing that would ever cause this to fail would be, for example, if you're writing to a directory that doesn't exist, or if this logger piece failed, or maybe app settings JSON, right, couldn't be found. So the idea here is to be a little bit more robust with our main application startup process and to be able to get things moving quickly. The last piece is when we're building our web host builder, we want to tell our web host that we're also using Serilog. This is a way to be able to, push it so that it also is aware that everything is being done. The last piece, if you want to do some extra stuff, is Serilog also has, as part of the ASP.NET Core extensions, an ability to do additional request logging behaviors. And this is where that diagnostic context that I was talking about, the logging context, you can inject whatever it is that you might want to into these logs. I included this as an example of I want to inject the requesting user identity in every single log entry. This is not necessarily the greatest way to do it. I'd maybe put the user ID or something like that rather than actual usernames. But the idea here is I can do something here in my pipeline build that says, do this for every single request. Now, it's important to remember the way that an ASP.NET environment is configured. I do the Serilog request logging after static files so that I don't end up getting a log entry for each and every one of my static files. It's something I don't necessarily care about. I don't need that extra logging behavior. The rest of the application is configured as needed. Inside of our app, then, anywhere that I need to do logging, I can simply inject an iLogger of my particular type. Notice these are all Microsoft extensions logging. We're not doing anything Serilog specific. This is all straight Microsoft code. We bring that logger instance in, and then I can do things like logger, log warning, log information, log error. That's all that I need to do within my application to be able to actually write these log entries. Now, then, as we go and look, we can start to see where all of this information comes together and gives us a nice overall set of project information. So you can see here, we actually see starting web host. Oh, user profile information is available. And here's where we get the user profile information, data protection keys, those kinds of things. And the idea behind this is now we can see what's going on within our application. If we turn Microsoft's information right to that informational level, we can see here that this is that correlation ID based on our config. And everything from this row to this row represents a single HTTP web request that was responded to by ASP.NET Core. So if we just do a little bit of looking here, what do we end up seeing? So this is a message out of Microsoft, which says request starting HTTP2. It was a GET for this particular URL. We're executing this endpoint, logging home controller index. We matched by using this route. So if you messed up your route tables, you weren't unsure why it was done, this tells you everything that it was doing and how and why it came with what it was looking to do. And then we see things like executing action method, executed action method, so start and end, executing view result with this view, executed with this view, and it took this much time, executed action, so this is the end of the above, and then executed endpoint, which is here to here. And you'll see all of those individual bits. And then this last line here, before this request finished, this is what Serilog's ASP.NET Core stuff adds for us. And it takes this above information and summarizes it into a single informational message. HTTP get of / responded 200 in 417.98 seconds of response time. So with this information, right, you're able to kind of look at as much as you want. Obviously, in a production heavy, volume environment, it may not be, something that is recorded every single time. As you're going to do some of this, right, this is where you'll see things and executed, whether it be source generators could automatically add things, like people automatically do things like adding, the handling of iProperty, notify property changes. You could also use it to do something like a before execute, after execute. So for example, your own authorized attributes and those kinds of things. So there's definitely a lot of ways to automate some of those log entries. I would encourage you in some ways, though, as much as you may be able to use source generators to do certain things, logging, although it does take time to write these messages, it is something that is important enough that you don't necessarily want to let anything automated do that, because we want to be careful with privileged information. A great example of why we have to really write these log entries ourselves is what happens if we look at what Microsoft writes for us if we were to execute things such as entity framework queries or otherwise. So what I'm going to do is I'm going to run the application real quick. You guys probably won't be able to see it just with the screen sharing limitations here. But what I'm going to do is I'm going to go ahead and try to have it do a couple of things here. And then I'll update the log message here. So I put in a username and password, tried to go ahead and log in. I'll close out of the log file here. So now we can see here, I have information that was written. Oh, I executed this database command. The parameter was normalized username. Notice there's no value in here. Command timeout was 30 seconds. Select top one, all of those columns from ASP.NET users where normalized username equals normalized username. Now, this is something that if we used a source generator or something like that to try to automatically build, it is very possible that we would not have gotten the same sanitization, or maybe you can do it on your own. It's something that you just have to take a little bit of a look at what you're accomplishing, and see how much or how little you're going to be able to get completed all on your own. But the idea here is as much information as we can write and as structured and actionable as possible, we're going to be able to do then other things with our logging tools, whether it be a manual review, automated review, system review, to be able to pull things back out. And then again, we can dial things up or down. As you see here, the example that I had before was very verbose. I moved things to only warnings out of Microsoft, and you'll see here that when the application started, I only saw the summary messages that were written for me by Serilog, and then entity framework, those database commands are there. So you can control that variability really, really quickly. If we go and take and do that same thing and change Microsoft back to debug, and I run the application again, even if I just view one page, which is all I'll have it do, that one page is going to write substantially more information. Now, this is where you get all of the detailed information, but you can see here that not only did I get all of the detailed information, you even see that I got some browser link information output because we're running from a developer environment, and those kinds of things. So your ability to kind of control this, to move things up and down, is going to be there, but what you include in those login is something that is ultimately, right, your developer responsibility. For me, anytime I review code and I see a developer do a log message template that looks like this, where I'm asking it to dump that object, I want to be really, really careful. Because again, as a reminder, if I do that as a dump and I try to get it to log that information out, you'll see in that log file much more information in here than what you expect. So here's that user identity. So I'm not logged in, but I still see all kinds of things that aren't really of any value to me from a debugging perspective or diagnostic perspective, and very well could have had some sort of privileged information in it. So my hope here is to have given you some tools to be able to take your existing applications, to be able to configure them a little bit better, to be able to do things. I constantly update this sample that's out here as new .NET versions come out to try to keep it as accurate as a starting point as possible. I'm going to take the question there about the use of source generators of automation. I'm going to take an action item to see if I can come up with something that would be a little bit better overall. So the question there was kind of talking about it being labor intensive and using source generators. I've never thought about creating an example of how you would do that, but I'll take a look and see if I can come up with an example, and I'll update the GitHub repository if I can, to see about a way to use a source generator to do something there. I think you'd get a little bit verbose in the scenarios that a source generator would make sense, but maybe not. So I'll take a look and see if I can come up with something, or if you've got a specific idea of something that you'd like to accomplish, send me an email after we're done with the session tonight, and I'll gladly take a look and see if I can come up with something. That's a question that's never came up, and would love to be able to get you something, one way or the other, of how to work with a source generator and logging. So great question. With that, I will, pause here for a minute, see if we have any questions. Otherwise, I'll turn it back over to group leadership here, and really do appreciate everybody's time this evening.
Any questions? Feel free. Otherwise, remember there's some next month we'll talk about don't build a distributed monolith, avoid doing microservices the wrong way. And I'll post the links and information from the GitHub repository with the meeting. And then I'll post the links to the recordings on Meetup as well. All right. Thank you very much. This is a great talk, Mitchell. So I appreciate that. And I've learned a lot too. Thank you.
All righty. Thank you guys. Appreciate it.
Have a great evening.